So sodium carbonate, we're told, contains sodium ions and carbonate ions. The atomic number of sodium is 11. What is the electron configuration? Okay, so if the atomic number is 11, that means it's got 2, 8, and 1 electron arrangements. 2 in the first, 8 electrons in the second, and 1 in the final energy level. This makes it unstable. So to become stable, it's going to lose that electron. So we're looking for an electron arrangement that's going to be 2, 8, and that is going to be option B. Explain why sodium carbonate cannot conduct electricity when it's a solid, but a solution can conduct. Okay, so what we need to say here in a solid, so we have got the ions are held in an ionic lattice and are not free to move. Okay, if we have the solution, then here is the lattice is broken and the ions are free to move. So in terms of marks for this one, you're going to get 1 mark up here for saying the ions cannot move, and then here we need to say that the lattice has been broken, so the ions are free to move. Okay, there's the marks for that particular question. Okay, next one. Calculate the percentage by mass of sodium in sodium carbonate. Okay, so we're going to use this equation here. We want to work out the mass of the element. So here we're working out the percentage of sodium. So according to this formula, there are 2 sodiums, and each sodium has a mass of 23. So we've got 2 times 23. And then on the bottom, we've got to work out the mass of the whole formula. I'm going to do that separately. I don't want to get in the way of what I'm doing. So the formula is Na2CO3. So as we've seen, there's 2 sodiums, there is 1 carbon, and there are 3 oxygens. And put the numbers in place. So I've got 2 times 23 is 46, 1 times 12 is 12, and then 3 times 16 is going to be 48. Add all those together, and that gives me an answer of 106. So all I now do is put the 106 here, and we're going to times that by 100 to get a percent. Let me put that into my calculator. So I've got 2 times 23, which is 46, divided by 106, and then times by 100, and I'm getting an answer here. I'm going to 1 decimal place of 43.4% as a final answer. Please just check on these type of questions that it doesn't want you to give a certain number of decimal places, because they do give you an extra mark if you do that correctly. In terms of marks, you can get a mark for working out 106, a mark for saying 2 lots of that, and then a mark for your final answer. Okay, I think this is the last question on this paper. It's a 6 marker. So the students has got 3 solutions, or 3 solids, sorry, and what we have to do is identify which of these they are and explain some of the tests. Okay, so use the observations to identify which solid is which. You explain how the test results help you identify it, and word equations to support your answer. Okay, we need word equations as well. So what I've done is I've taken the information from the table to here, just to help me navigate this with you. And I'm going to start with solid A. And again, I've written this down so I can just talk through it rather than write it at the same time with you. Okay, so solid A, we have got it reacting with an acid, and it's producing bubbles, which means it's making a gas. But the gas doesn't affect lime water, so the gas is not carbon dioxide. But when it's tested with a lit splint, the gas burns with a squeaky pop. So because it burns with a squeaky pop, this means the gas is hydrogen. So this reaction here, one of these chemicals that makes hydrogen when it reacts with acids is a metal. So I have got a metal plus acid makes a metal, salt, and hydrogen. So that means that A must be zinc from the list of chemicals. How do I know that? Because bubbles of gas are produced. The gas that is produced burns with a squeaky pop, therefore the gas is hydrogen. There isn't any carbon dioxide formed because the lime water does not go cloudy. And then remember, it wants a word equation. So here's my word equation, zinc plus sulfuric acid. So it's going to make zinc sulfate because it's sulfuric acid makes a sulfate. And then we get hydrogen gas produced as well. So that's A done. B, let's look at B. So B is a blue solution is formed. Some black solid remains. We haven't got a gas being produced. And here we've got no gas being produced. So this example here is a neutralization reaction. And because of the way this is working, this must be the copper oxide because we're taking copper oxide, we're adding it to sulfuric acid, so this is an acid and a base. We get a salt, copper sulfate, and we get water. Copper sulfate is a blue colour, so that helps us match up one of the observations. So what we say here is that B is copper oxide. There isn't any gas produced because it doesn't make a gas when it reacts. The copper oxide is black. It's insoluble, so it's left at the bottom when it's finished reacting. And the copper sulfate solution is blue. And again, we've got an equation for the reaction. And the final one, C. C must be the sodium carbonate. We've not done that. Let's just check why. So here, again, we've got bubbles, so gas is being produced. The gas goes through lime water, it turns cloudy. So if you're getting carbon dioxide produced, because it goes cloudy, you must have a carbonate reacting. This is the only one with a carbonate that is reacting. And we know, or should know, that carbon dioxide will actually extinguish, put out a lit splint. That's why it's used in some fire extinguishers. So let's go back to the answer. So identify the chemical, it's sodium carbonate. Give the equation, so here I've given the actual equation again, so it's sodium carbonate with sulfuric acid, makes sodium sulfate, that's the salt, plus water, plus carbon dioxide. I've got bubbles of gas, that's the fizzing. The gas turns lime water cloudy, therefore the gas must be carbon dioxide. Hydrogen is not produced, and therefore we don't get a little pop when we put a lit splint in. In terms of marking this, these are always tricky to mark. To help simplify it, I've got 22 bullet points. So each one of these is a bullet point. There's 22 bullet points in total. So if you've got 19 of them or more covered, give yourself 6 marks. 5 marks if you've got 16 to 18, you get the idea. 4 marks is 12 to 15. So use this to give you how many marks you have got in your answer. Remember, when you do your answer, you can't write it in bullet points. You've got to write your answer in paragraphs so it makes sense and is logical for somebody reading your work.